Now, today's lesson, we're going to start by basically just having a quick overview of what we do when we reduce trig expressions from big angles to smaller angles. And we have a couple of different ways we can do this. The one is to convert negative angles to positive angles. We can reduce angles greater than 360. We can use the reduction formula, and we can use cofunctions. Now, those are all fancy words. In reality, what you do is that you use the cast diagram. So the cast diagram, and you visualize a particular trig expression. So, I could say the cos of 210, and you either reduce it off the horizontal axis, in which case the trig ratio stays the same, or you can reduce it off the vertical axis. And if that happens, you use the co-ratio of that trig expression. So I just want to do a little bit of a review of how this works, because we've done 2 lessons already, but I know this can get tricky. So I'm going to divide it up into 2 parts. I'm going to say on the left-hand side, so let's actually get rid of this bit here. On the left-hand side, we are going to use the horizontal axis to help us reduce. And on the right-hand side, we are going to use the vertical axis. And an example of what I could do is I could say to you, reduce the sine of 210 using the horizontal axis or using the vertical axis. And the way this is going to work is you say, look, if I'm using the horizontal axis, I would just rewrite 210 as 180 plus 30. And that shows me very clearly how far away the sine of 210 is from the nearest horizontal axis. And I'll do a little cast diagram up in the top here, just so we can keep track of where we are. It looks to me like we're in quadrant 3. So this last little bit is 30. If I want to reduce this off the vertical axis, the nearest vertical axis is going to be 270. And so I would write this as 270 minus 60. Now, I haven't reduced anything yet. I've just rewritten it. But in the one case, I'm using the nearest horizontal. In the other case, I'm using the nearest vertical. Give me a thumbs up if you understand what I've done here so far. I haven't reduced anything, but I've just written it like this. Okay. Now, fantastic. If I was reducing it off the horizontal axis, in fact, in both cases, I asked myself, is the sine of 210 positive or negative? Tell me in the chat if it's positive or negative. And how do I know if it's positive or negative? What do I look at? Maybe someone can come online and tell me what makes it positive or negative. What do I have to look at? Who's willing to offer their opinion? Fatejo, you are on the money. You look at what quadrant it's in. So it's in quadrant 3, so it will be negative. Yeah. And if you are using the nearest horizontal, you simply write the same trig ratio and you type and you get minus sine 30. So in your calculators, type sine 210, then type minus sine 30, and just confirm for me that you get the same value, that this is the same as this. So just give me a yes if it is and no if it's not. Okay, so it appears I'm good for that. Now, that's one way of reducing a obtuse angle, but there's another way using the vertical axis. And what we often call this is using a co-ratio. Now, if we use a co-ratio, the first step is the same. Sine in quadrant 3 is still negative. But when using the vertical axis, we don't write the same trig ratio. We write the co-ratio of sine. And the co-ratio of sine is cosine. That's not an accident. It's complementary sign. So cosine. And so we write minus cos. And then the angle we write is minus cos 60 because it was 60 degrees away from 270. And again, I want you to check, if you type minus cos 60 in your calculator, do you get the same value that you got for minus sine 30? And if you did, give me a yes. If not, give me a no. Okay. So what is, let's go to Leolo, your question.
Hi, sir.
Hey.
Sir, can I just ask, why is it negative cos 60, not like negative sin 60?
Okay. When you use the vertical axis, or what we call co-ratios, to reduce a trig expression, you have to change from the original one to the co-ratio if you use the vertical axis, which is 270. Cool. So that's a rule. And we're going to practice that now. And the reason I'm doing this is I know students get confused, but once we've done a couple, I promise it becomes super easy. So we're going to use the same idea, except now I want you to reduce the sine of 330 using the nearest horizontal. And then on this side, I want you to reduce the sine of 330 using the nearest vertical axis. Go ahead, and I'll call this A, and I'll call this B. And tell me, and you can tell me in the chat what you think my answers should be. And remember, the left-hand side, horizontal. Right-hand side, we're using the vertical axis. Who would like to have a go at the first one? Anybody willing to volunteer as tribute? No, I'm joking. Or you can pop it in the chats if you. Ungani, let's go to you. What do you think we should do for A? Oh, I think we might have lost Ungani there.
Sir?
Yes, how's it going?
So I think you should say that sine 360 minus 330, which will then give you 30. Sine, you have to say sine 360 minus 330, which will then give you 30. And then...
Wouldn't you rather say 360 minus 30 to get 330? So like, do you know what I mean? Like this one must have the same value as that one there. What would you do from that next step?
As my final answer, I got negative sine 30 because sine is negative in the fourth quadrant.
Perfect. So you would get minus sine 30 because you know that in the fourth quadrant it's negative. Perfect. Thank you so much. Is anybody willing to share on B? How would you do B? So it's the same value, or it's sine 330, but now we're using the nearest vertical axis. Let's go to Matete. Matete, what would you do? Can you hear me? So I think maybe we've got some audio issues. I think Matete would have said something like 270 plus 60. And notice how I'm focusing now on a vertical axis is 270. Just remind you where the vertical axes are. There's one here and there's another one here. Or if I was going the other way around, I could say this is minus 90 and this is minus 270. If you think about your angles going positive from here and negative from here. So what is my answer for this one going to be? It's going to be still negative because sine is negative, but this should be cos 60. Okay. Everyone, why do we use 270? So Naledi, I am deliberately telling you, so I'm artificially creating this context where I said, I want you to use a co-ratio or use the vertical axis to reduce it on the right-hand side, and you're using the horizontal axis on the left-hand side. So I'm forcing you to do it because I want you to be comfortable using both ways. Okay, let's do one more. Let's say if I had the sine, I know I'm using sine a lot, but if I had the sine of 390, and I want you to reduce that using the nearest horizontal, and I also want you to reduce the sine of 390 using the nearest vertical. Can you go ahead and do that? Why is cos negative? So Cass, if you go back to the very beginning and you look at the sine of 330, this is what it started out in life as. And in quadrant 4, sine is always negative. So that's why this thing has to be negative. The fact that we're reducing it off the nearest vertical axis, so that's why I've got my 270 plus 360. I'm writing it in terms of the nearest vertical. That's why it has to go from a sine to a cos. And that's a rule that we have to follow, that if we use a vertical axis, we switch from a sine to the cosine. Now, that's quite a useful thing to know how to do, and that's why I'm kind of forcing you to know how to do it. Okay. But now I've taken it up a notch because I've said 390, which is greater than 360. So what happens with that? So I see Cody and Tebogo and Kiribetswe and Sonic are all giving the same answer. It does look to me like it's in quadrant number 1. And, I could, in the previous lesson, sometimes I was skipping the step and I was just saying, look, I can see it's 30 degrees away from the nearest horizontal. I'm good. But I think it is important to see how I'm seeing it in this first step. And then I would go plus, because it's in quadrant 1, sine 30. Now, the second one is a bit harder because I'm forcing you to use the nearest vertical. Now, what's the nearest vertical? It's going to be this one over here. And, if this was 360, I guess if I added 90, this would be 450. But I suppose the important bit is just this bit over here. Who would like to try and explain how I reduce sine of 390 to a cos? Maybe. Now let's go to Kat.
Hi, sir.
Hey.
So I said, first I had to figure out what 360 plus 90 was.
Yeah.
Since it was the nearest vertical. And then I found that it was 450.
Yes.
So I then said 450 minus 390 to find the co-ratio.
Okay. So I was thinking, so there's a couple of ways you could do it. Did you end up getting, I was just thinking of writing it like 450, because I wanted that minus minus, what did I have to start with? 330. So I wanted to get, sorry, I'm having a moment here, minus 60. I was just thinking you could do it like that. And then you would say in that quadrant, it's positive. and then it would be cos 60. So did you get 60, cos 60, Kat?
Yes.
Okay, so we used the same, we got the same answer, so that's fine. Perfect. How did we get 450? So I was just saying, where was the nearest vertical? And the nearest vertical axis was just going to be 450. However, what you could do, and I'll show you this other way, what you could do is, if you want to reduce something, you can always subtract 360 from it. So you could say 390 minus 360 is the same as that. So it would be the sine of 30. So, because you can always take away 360 and it's not going to change the trig ratio. And then you could say, well, in quadrant that's going to be positive, how far away is 30 from the nearest vertical? It's just 60 away. And you get that. So you could also do it like that. And then Kat was also using another way, I think. So I think, Kat, you said the sine of 390. Maybe, Kat, what did you, let me just ask you to come back on. What did you say? So the sine of 390.
I first first added 90 degrees because it was above 360.
Okay, so then what did you get for the first bit? So you got
390 plus 90.
390 plus 90. Now, I don't think you can do that because you would get sine of 480. Can you see what I mean?
Yeah.
Yeah, but as long as you get the same answer as me, there's two ways that I can see, but there might be other ones. The one is to say, look, the nearest vertical is 450. It's just 60 degrees away. But there are other ways to do it. Funeka said, I did a different way and I ended up without me using the co-ratio. Would it be wrong if I got sine 30? It's not wrong to get sine 30, but if the question said you must leave your answer as a cos, you need to then know how to go from sine 30 to cos 60. Okay, so I know 80% of the time you'll be using this one, the horizontal. It's much easier because it just stays a sine the whole time. But it is important to have a co-ratio conversion in your locker so that you know how to convert something in that case. So let's just do one more and then we'll move on, because I can see some of you are feeling a bit, huh? Let me do the sine of 150 and the sine of 150. So on the left-hand side, you are using the normal reduction formula using the nearest horizontal axis. On the right-hand side, I am forcing you to use the nearest vertical axis. And what that will mean is that you use a co-ratio reduction and the sign will have to change to a cos. So I want everyone to have a go at this. And I think after this one, we'll all feel a bit better about this. Okay, so Ukulezo Zulu, I hope this is helpful. Just hang in there now. I'm sure we'll get there. So Yazi, I just see your question in the chat. How and why can't we subtract 360? Yazi, we absolutely can subtract 360. And so I do hope I answered your question. Just let me know in the chat. There's a couple of different ways to do these. And I would say whatever works for you, as long as we're getting the same, we're all good. So you should be getting plus sine 30 for the one on the left-hand side. And so, you can, as you get better at these, sometimes you find, I wouldn't recommend it unless you're very comfortable, but sometimes you can go straight to the answer like this because well, it's 30 away and it's positive. But this intermediate step helps you understand that. this one, the nearest vertical is going to be 90. So this is going to be 90 plus 60. And this is going to be what? I'll give you a bit more time. Veda's given an answer. Sonic has given an answer. Let's give a bit more time for a few more students. So you always ask yourself, is sine of 150 going to be positive or negative based on the cast diagram? So 150, sine is positive, so this has to be positive. Because this original thing was positive, it can't suddenly become negative. But because we are using the nearest vertical axis, it changes from a sine to a cos, and we get plus cos 60. Now, if your teacher is telling you the truth, the sine of 150 should in fact be the same value as the cos of 60. So put this in your calculators and see what you get for sine of 150, see what you get for cos of 60, and let's see that they are in fact equal. Otherwise, my reduction formula is not working so well. If it is to say like a y, and if it isn't to say n, okay, so what have I taught you in this first half an hour today? Hopefully, I've gone over that there are two different techniques that you can use to reduce trig expressions. You can use the horizontal axis, and most of the time you will use that, like 80 to 90%. But in some situations, you do need to go from a sine to a cos or from a cos to a sine, in which case using the vertical axis and what we call the co-ratio reductions of the tool that you need to use. So Tata, I wouldn't worry. There's different ways of getting to the answer. Why is the cos positive? Ongani has asked. So Ongani, it always goes back to the original. So when we started this question, we had the sine of 150. And at the beginning, the sine of 150 is positive in quadrant 2. So the sine, positive or negative, comes from the original ratio. That's why this is positive. If I had said to you instead that something was in a different quadrant, say, for example, I said to you the sine of 210, the sine of 210 would end up being negative because it's in quadrant number 3. So we would just use what, it always goes from the original thing as to what quadrants it's in. Okay. Can we have a quick vote? It's always asked, so can you further explain example B? Okay. So which planes are cos negative in? So if you go back to, I would really recommend having a look at the previous 2 lessons, but just a quick follow-up. Cos is negative in this quadrant and this quadrant. So everything is positive in quadrant 1. Only sine is positive in quadrant 2. The other 2 ratios are negative. Only tan is positive in quadrant 3, and only cos is positive in quadrant 4. So, for example, sine is negative in quadrant 4. Okay. Cool. What we're going to do now is we're going to take a little break. And what I would highly recommend is we've now done about 2.5 hours on the reduction formula. If you go back and watch the original videos, you will see the system coming through again and again. But just for now, we're going to take a break. And then after the break, I'll make a decision about if we do more of these or if we carry on with a new topic. Okay. Actually, before we do that, let's do a quick vote. Thumbs up if you're feeling like you understand how to reduce things using the horizontal and the vertical axis. Thumbs down if you feel quite unsure. And you can be honest, it's not a problem. I just want to get a feel for the room. Okay. Keep those votes coming. We're going to do a little break though first. So regardless, I'll look at the votes when we come back, but we want to stand up for a moment because we're working hard for half an hour. So if you can just stand up with me for a second. And we're going to stretch our legs out. I can feel my brain's been working hard. I'm sure your brain's been working hard too. So to start by just swinging your arms around a little bit. So, okay, so swing your arms a little bit. Feels good. You're loosening up. You should find yourself becoming more relaxed. And then what you can do is you can just roll your shoulders back a bit. So just roll them back. Now then you can roll them forward. And then give your poor neck a break by just stretching it to the side. 1, 2, 3, 4, 5. Stretch on the other side. 1, 2, 5. Okay, then let's do some circles. So like this, small circles to start with, and then slightly bigger circles, and then the biggest type of circles. Okay, then just shake it out again. Hopefully that's got some blood going in your body. And then let's do some high heart rate stuff. So what we're going to do, we'll do knee taps. We go 1, 2, but except we do it 1, 2, and so on. And let's start with 10 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Woo! And hopefully your heart rates have been raised. And I would highly recommend a glass of water if you've got one nearby. Okay. So just a quick, we have brought back Maths 24 for today as the puzzle game. So for those who haven't played before, you're given 4 numbers. You have to make 24, and you can use each number once, and you're only allowed to use brackets and the 4 normal operations. Ooh, I can definitely feel my heart rate went up.
Yes, you did.
Which is the point. So that's good.
Oh, guys, it can't be that bad.
So 5 times 1 plus 8 plus 8. Issa, that's 21, huh? So you're not quite there yet. So what other ways do we have of getting to 24? So I'll give you a hint. If you go 5 minus 1, you'll get 4. So you've used the first 2. Can you get to 24 using those last 2 8s? Can you get to 24 using those last 2 8s? Can you do it?
Yes, you can.
Such a catchy slogan. Yes, you can. Simple things, eh? Sure. Cass, I think you may have got something there. So Cass has said, and you're getting some support from the rest of the students, 5 minus 1 is 4. And then if you go 4 times 8, you have 32. And 32 minus 8 is 24. Yes. So if we wrote it out the long way, you went like that, and then you went like that. Okay, now that was the warm-up one. It's time to go blue. So we're taking it up a notch. Can you get to 24 using these 4 numbers? Can you get to 24? Now this is for some serious respect. So What would I do? These ones get trickier. Ooh, Tova and Tato have said 8 times 2 is a good place to start. So 8 times 2 is 16. And then 16 plus 7 plus 1 does indeed give you 24. And Paul agrees. 8 times 2 plus 8 times 1. You would need an extra 8 for that. 7 plus, okay, Cody agrees. It seems like we have got, are there any other ways of doing it? But I think you guys are right. I was thinking 7 minus 1 is 6. And 6 times 8 is 48. And then 48 divided by 2 could give you 24 as well. But I think Charlene, yeah, Vaneka, Cody, Kiribetswe, you're all agreed. So we'll go with the most correct answer for today is to go 8 times 2 plus 7 plus 1. And that will give you 24. So
nicely done, guys.
Well done. Okay, let us get back to the main trig for today. So what I would say, I'm going to move on to the next topic for today, but re-look at the first half an hour of today and using the reduction formula. It will be helpful to you, but it is, I think, a good time to move on to trig equations. So what is a trig equation? I've prepared a nice little example here to show you one. So there's a couple of different ways you can solve a trig equation, but the one here says that the sine of x is equal to minus 0.4. So that's a trig equation because you have to solve for x. But the thing about trig equations is that they don't just have one answer. So looking at the graph of the sine of x, I want you to try and think of which of the 4 options you think is correct for this equation. And it said the domain is between 0 and 360, which makes sense because that goes from here to here. So pop it in the chat what you think is the correct answer. Your Kat says your general solutions. Kat, I'm going to make this your favorite section in trig. Honestly, you're going to be like, when you're done with this general solutions, you're going to eat them. Like 8 marks in the bag. Moving on. Thank you very much. And I'm not joking, being deadly serious. Okay, but before we get to that, let's just understand what the answer to this one is. So you are trying to solve the equation, the sine of x equals minus 0.4. You need to find what value of x would make that true. Now, to help you, I've given you the graph of y equals sine of x. And so I want you to think what x values, when you put them in your calculator, will give you minus 0.4. The graph might help you. So if I look at minus 0.4, I was thinking that minus 0.4 would be about here, like 1, 2, 3, wait, 1, 2, 3. Maybe that things are a little bit out here. Okay, so it's actually not perfectly on 1.4, but it's going to be somewhere. That's 0.75. Yeah, it's going to be somewhere around here. It feels to me like it's going to be somewhere in this neighborhood, because we know it's when the sine of x equals minus 0.4. Would you, like, does that make sense? Like the number is minus 0.4. When is the sine of x equal to minus 0.4? Minus 0.4 is down here somewhere. So I'm guessing that sine of x is somewhere around here. Like the answer to the solution is somewhere here. Now, the first thing I see is that I have 2 solutions. So that's something new. And to me, it looks like they're between 180 and 360. If I was guessing, like somewhere around 200-ish. And this one would be somewhere around 330-ish. Give me a thumbs up if that makes sense, like of how I'm doing it. I'm doing it visually, like I'm not doing it using algebra. I'm just literally saying, where is this equal to that? Okay, well, let's have a look at our calculators. So why don't you put the sine of 200, take your calculator and put the sine of 200 and see if you get something close to negative 0.4. Okay, so I'll slow down. I can see lots of you are feeling a bit confused, which is fine. All I'm trying to answer is this graph is the graph of y equals sine x. And on this graph, it can help me find the solutions to the equation. Okay, so if I put 200 in here, I get minus 0.34. So I know that 200 isn't the correct answer, but it's close. Now, using my guess, what if I put the sine of 204 in? What do I get for that? Can someone tell me in the chat, what do you get for the sine of 204? Are we getting closer? Is that closer to minus 0.4? Yeah. So the sine of 204 is minus 0.4. So one of the answers to this equation is when x equals 204. Now, if I look at my drawing, I see 336 on this option. Can someone try and see what you get for 336, the sine of 336? So I'm looking at the chat, and what I'm seeing is, again, I get minus 0.4. So it feels like two of the answers that I could get for this trig equation is, or rather are, 204 is one answer and 336 is one of the answers. Give me a thumbs up if that makes some sense to you now. Like, I'm just looking for answers at this stage. I haven't given you a method. I've gone fishing, basically. And I found two. Now, I'm going to be a little bit sneaky. I'm going to add 360 to 204, just to show you something interesting. So if I add 360 to 204, 360 plus 204, I get 564. I want you to type the sine of 564 in and see what you get. What do you get for the sine? So if you round off, you get minus 0.4. Now, this is rather remarkable because that's the same value, which means that 564 must also be an answer. And let's use the same idea again. If I go 336 plus 360, I think I get 600 and, let's have a look. 696. So can you put that in your calculator and see what you get? What is the sine of 696? Okay, and I'm sure by this point, you're not that surprised. Again, it's negative 0.4. So one of the things we need to think about when we are solving for a trig equation is that you don't just get one or two solutions. There can be many of them. And so what I need to do is teach you a method for finding the general solution for a trig equation. The general solution will give me all of the answers. Okay, but we'll talk about that probably in the next lesson. The other thing I want to make the connection with is that a trig graph can also show you solutions, because where the sine of x equals minus 0.4 is going to show you the answer. So that's why when I looked at this graph, I looked at these 2 points and I knew that probably the correct answer would be C. Can you give me a thumbs up if you understand how I could see C was the answer from the graph? And give me a thumbs down if you think I have no idea how the graph is meant to tell me the solution here. Okay, so there's a mixture in the room. That's completely fine. It's what I would expect. Let's do another question like this, and then we'll go from there. Okay, I would say the majority are still feeling confused. So don't worry, let's do another one. But here's another question like this. So the trig equation that I'm giving you says that the sine of x is equal to 0.6. It's an equation because we're trying to find what value of x will make the sine of what gives me 0.6. Now, I've given you a whole bunch of options at the bottom, but I've also given you the graph sine x equals 0.6. Or, sorry, I've given you the graph y equals sine x. Using what I just did above, can you try and work out which of these four options is correct? So if you look at this, and I want you to just look at the drawing, just estimate which one do you think is, and maybe someone can come on and tell me what's the first step that I need to use here. Like, where would I look on my graph? I'd love someone to maybe explain where I go looking. Anyone willing to give me some directions? Where should I go look? I remember in the last question, I drew a straight line somewhere. Look at your 90, okay. But wasn't the 0.6 quite important? So if I think of 0.6, I think 0.6 is about here. So I think, oh, I think my thing just changed. It said, there we go. So it looks to me like the graph equals 0.6 at these 2 points. And this is in between 0 to 90 is quadrant 1, that's quadrant 2. So if I was guessing somewhere around 30 and somewhere around 150. Now, which answers seem closest to that? Well, this is quadrant 1 and quadrant 2, so it's not that. It could maybe be this one. It isn't that one. So now I have a little bit of I'm uncertain. It could, you know what? I don't think it's C. The reason I don't think it's C is X is 53.3, and I suppose it could be, but I think it's more likely to be A, but I'm not for sure. So here, grab your calculator and type in your calculator shift sine 0.6. And what do you get in your calculator if you go shift sine 0.6? So I'm actually evaluating what this X is now with my calculator. So in the chat, what I'm seeing is if you use your calculator to go shift sine 0.6, we get 36.87, which means I can reject this one. And so the two answers are going to be 36.87 and 143.13. The answer is going to be A. So I used my calculator to help me in that scenario. Let's just do another vote. I see Irene and Kobotso have also given us Sandisile. Thumbs up if you understand from the graph why it had to be A. Thumbs down if you feel like you don't understand how it's connected. How would I get the 143.13? Chapang? So it's got to do at this stage, the way I actually get it is I go 180 minus the original angle. But because it's a multiple choice question, I basically knew once X was 36.87, and I could see on the graph the other answer was before 180, I knew it had to be this one. Okay, so let me start teaching you my magic method for general solutions. And I promise you, once you know how this method works, these things get easy. So we're going to bring the cast diagram together with finding what I call the general solutions. And I'm going to start with question 2. And here is how my method works. So step 1 is you look at your trig equation and you ignore any negative signs. Okay. Mitchell, you may have got your calculator may be set on radians, not degrees. That could be part of the problem. Okay, step 1 is you find the reference angle. You ignore the negatives and you go shift cos 0.231. I want to know what you get for that angle. So you go in your calculator, you go shift cos or inverse. It kind of looks like that. And you get an angle. What angle are you going to get? Okay, so you get 76.64 is what people are saying in the chat. And if there's a different answer, please let me know, because I want to know if that's correct or not. Okay, fantastic. Now, based on the example of the graph I just showed you, I think we've established that often trig equations have more than one answer. And this is where we're going to connect the cast diagram. If I say to you, what quadrants is cos positive in? Is it positive? What quadrants is cos going to be positive in? Given that the question has cos is positive 0.231. So I want to know in the chat or someone to come along, what quadrants will cos be positive in? So cos is positive here and here. Okay, fantastic. Now, if you go back to our reduction formula videos, maybe like video 2 or video 3, we talked about how every angle can be written, basically all the angles in quadrant 1 can be written as theta, in quadrant 2, 180 minus theta, quadrant 3, 180 plus theta, and in quadrant 4, 360 minus theta. Not all of you were with us, but if you remember knowing that all angles in quadrant 1 are like this, and 2 like this, give me a thumbs up, just so I know kind of how many people have seen this before. If you go back and watch the videos, you'll see where that came from. Okay, now, this is where the awesome thing comes in. I want to suggest to you that the solution to this equation is in quadrant 1 and quadrant 4, because that's the only place where cos is positive. So you write out, I write like a Roman numeral to indicate quadrant 1 and another Roman numeral to indicate quadrant 4, because that's where the answers are. Then I go, what was my reference angle I got at the beginning? What was theta? It was 76.64. So I go, theta is equal to 76.64 plus k times 360. Now, k times 360 is just that like 360 that I was adding earlier on. I'll talk more about this in the next lesson, but basically the solutions repeat themselves every 360. Then that's the solution in quadrant 1. The solution in quadrant 2 is going to be theta is 360 minus 76.64 plus k times 360. And then there's this funny thing that your teacher possibly wrote where it says k is an element of the integers. I was wondering, does anybody know what that k backwards ez means? Does anybody know what that means? And why do we include it? So all it means is that we can add any multiples of 360 to this answer as long as the k is either a positive 1, positive 2, or a negative 1, negative 2, and so on. K can be any integer. Okay, it's not that important. K is not any real number, Cody. K is any integer. That's why there's a Z there. Now, what are the final answers going to be here? 76.64 plus, and I know this is a mouthful, so the whole of the next lesson will be based around this. But let's just go 360 minus 76.64. What do you get if you go 360 minus 76.64? This bit here. Who has an answer for that little yellow bit? So we get 283.36. Okay, now here is where we need to see if things are working out well for us. I want you to type in your calculator the cos of 283.36. I also want you to type into your calculator the cos of 76.64. And I'm really hoping that you get 0.231 or something very close to that. Because if that is the case, then you found solutions. Okay, Veda, you know what? Some teachers, instead of using 360 minus theta, they use positive negative, and so you'll get the same answer. So I'll talk about that more in the next lesson. So it's not wrong. You could have written plus minus 76.64 as well. Okay, so I'll talk more about that in the next lesson. All I wanted to do today was give you this three-step process. So give me a thumbs up if you feel like both these things are an answer to this thing over here. Okay. And now there was a question asked, could the answer also just be theta is plus minus 76.64? Yes, it could. And I'll talk to you in the next lesson about why that is. But what I really want to focus on for today is I want to focus on this three-step process. Step one is to take the trig equation and ask yourself, ignore the negatives and find a reference angle. So that's step one. Step two is to ask yourself, which quadrants is this trig ratio positive or negative? And then step three is to write the answers like this. Should we just try, let's just try one before we go. I want you to try and do question 4. So let's just do the three-step process. Sorry, Lebo, we're just going to run 2 minutes late. I just think that it's important we practice this. So I want you to mimic exactly what we just did. And I want you to try and solve, oh wait, no, that's a wrong one. Sorry, let me change this. That doesn't work. So let's make it the sine of theta equals 0.43. So I've changed the question because the other one doesn't make sense. Solve the equation, the sine of theta equals 0.43. And I just want you to try and solve it using the steps that I just did now. Okay, and I know some of you are feeling confused. Don't worry. We have a whole nother lesson on this. But let's just see if we can do it. Sine of theta equals 0.43. So maybe someone can put it in the chat. What is your reference angle? Sine of theta equals 0.43. What's your reference angle? Okay, so 25.47. So that's step one. Now I need to know what quadrants is sine positive in. So Mpo and Andile and Khopotso have said quadrants 1 and 2. And so the answer must either be in this form or it must be in the form 180 minus theta. So because I'm in quadrants 1 and 2, I write the Roman numerals so I don't get confused. I know I have 2 solutions in quadrant 1 and quadrant 2. See if you can write out what you think I'm going to write out here for your 2 solutions. So the first one is 25.47 plus k times 360. Now, what about the second one? That's a little bit harder. So $154.43. And that's it. And if you want to check this, type in your calculator the sine of 25.47 and the sine of 154.43, and you should get very close to kind of, you know, the original number that we, oh, sorry, I don't know what happened there. I think see, I haven't worked, there we go. So in Paul, if you're writing a general solution, yes, you would. Yeah. Okay. Now, I realize I'm going to stop there for today. The whole of the next lesson is going to be based around this method. So all I wanted to do was sneak in a little bit of this into your head today. You don't have to stress. I'm going to start from scratch again in the next lesson around this. Okay. But I do hope this shows you that there's a very specific process you can do that makes general solutions actually very easy. Okay. And you've worked really well today. We've covered a lot of work.